Guys and girls, it's Know It time!
Alright, so today I will be actually going over the logs today. You will actually understand what logs is. I mentioned logs to you yesterday, but I didn't really go over it. I said yesterday's stuff was the precursor to understanding logs. Now, this is where the fun begins. Logs. Guys and gals, it's Know It time. Your favorite time of the day. Okay. Logs. If you look in your calculator, so grab your calculator out. There's the logs button. Every calculator will have a log button on it. Here, if you're using a TI-83, your log button is right here, log. Your calculator will have it. The problem is, a lot of people say, what the heck is that? What does it do? We know that 2 times 3 is a simple multiplication, but there's this unknown function called log. So let's play around with this calculator and see what it does. So we'll do log, I don't know, we'll just have some punching some rounding numbers, log 10. So we're going to punch this in our calculator, log of 10. And hit your button, which is equal to 1. So let's write that down, 1. Now, I still don't know what it is, so let's try another one. Log, maybe let's hit 100 this time. And just, I don't know, just for fun. See what is it like. Log 100. The answer is 2. Some of you say, hey, miss, you know, there's a catch to this. What's the pattern? Maybe I go log. Now, 1,000 is too easy. What I have in my my bank account right now? 10,000 rupees. Not dollars. I'm not that rich yet. Teachers, we're poor. 10,000. What would that be? 4. So you punch it in. Again, log 10. 4. What's a dollar rupee compared to dollar right now? 650. So how much is 10,000? That's, wow, that's like maybe a 400. No, that's less than 400 bucks. I'm pretty poor. Log of 10,000. So basically, now some of you say, hey, what's the catch to this? Anyone figure out the pattern yet? Without using your calculator, try this log. One day I wish to have $1 million. One day. Mark my word. Without using a calculator, and indeed it is 6. So some say, hey, Miss, no, the trick is this. Log just tells me how many zeros there are. Okay? If it was that easy, I wouldn't dedicate 2 weeks to teaching logs. Try log of 5. Some of you say, hey, there's no 0, so the answer has to be 0. But let's punch in log of 5 right now. And you be say, oh, I know. Log 5. And we do this, like, look. Wow, that's some weird, insane number. So, for now, log of 5 is 0.698. 0.698. So the question really becomes is, what really is logs? There's really no weird pattern. But I'm going to help you out. I kind of lied to you. There's actually one more number that I didn't show you. Calculators, let's write down a few things. Star. Calculators calculators work in base 10. Calculators work in base 10. So really, there's a small little number base here, but I didn't show you. The hidden number is 10. Hidden number here is 10. Hidden number here is 10. Oh, there's a hidden number. If I don't show the number, it's a hidden 10. Okay, so let's look at my numbers now. I'm going to highlight the first 3 sets of numbers for you, and maybe you can figure out the pattern. I have a 10 here. I have a 10 here. And I have a 1 here. I have a 10 here. I have a 100 here. I have, using only these numbers, 10, 100, and 2, I want you to create an equation that uses only 3 of these numbers that it equals. Go for it. Let's see how we can create an equation. Using only 10, 2, and 100, create an equation. Using only those to create an equation. That's what I would. Yeah. There's only one formula or one equation that uses exactly 3 numbers and it equals perfectly. 10 squared equals to 100. Hey, let's try it with let's use your new theory and let's use it with this. Let's see if this works. 10 1 million. Actually, if you go to I think I forgot what country. It's not Nigeria. There's one country where their $1 million is worth next to nothing. Zimbabwe, that was it. In Zimbabwe, their country is so corrupt that they have a $1 trillion bill, and and that buys you 1 loaf of bread. So people actually carry a wheelbarrow full of $1 million bills, thinking, "Hey, I'm a millionaire," but that really buys them nothing, because their currency is so useless. It costs more to print $1 million than to actually is worth.
Can't they just change their currency?
No, because it's so corrupt. Because the president there or something, it's Robert Mugabe or what happened? I forgot. Mugabe or whatever. It's so. You probably heard in the news when he came to power and he started chasing out after all the Caucasian white farmers, and he hunted them down, and then so they all ran away because he said his land. So they want no foreigners to invade his land. So then ever since that, there's no farming. And everything started going higher and higher as inflation kicks. So Zimbabwe is one of the most corrupt places right now. That's why their dollar is worth next to nothing. So their $1 million bill is worth about 2 cents to us. So yeah, if you want to be a millionaire, go to Zimbabwe. I'll make it rain for you. Okay? So guys, gals, look at this one. 10 to the power of 6 equals to 1 million. Okay. Now, what about this one? Why don't we try this? 10, try this on your calculator, to the power of 0.698. Let's see if it equals to 5, because according to all my work, it should. So let's go. It's close. Because I kind of rounded up 0.698. Hey, look at that. It's so close to 5. So really logs, well, there's a technical way of logs, but I like to write my own definition logs. Because I like to write my own things from scratch. Logs, really, the easiest way to understand log is this. Log is a fancy way. I know this for some people will not agree with this. But for you to understand, it's a fancy way of writing exponents. Because instead of writing exponent form or log form, I can go back and forth. The two are they're related to each other of writing exponents. Okay. So really, logs and exponents go hand in hand, just like salt and sugar, or salt and pepper. Just like me and Lamborghinis. So on one hand we have logs. On one hand we have exponents. Look at the pattern of what goes where. And I'm going to give you some more notes in a second. I have log. The basis will change once in a while. 2, 8. Without using your calculator, what do you think the answer is going to be? No calculators. Well, you can't use the calculators. So 3. It is correct. Because you're saying 2 to the what power gives you 8. Okay, so let's rewrite this using exponents. 2 to the power 3 equals to 8. See, logs and exponents, they go hand in hand. Question. Nope, or is it just stretching? Let's try this one. What if I give you this? Your job is to write the exponent form. I'm going to make it a bit more challenging. Log base n of g equals to O. Oh. What a coincidence. It spells something. No. Coincidence, guys. Figure out what is that going to be. I give you the log form. You give me the exponent form. N to the O to the G. Nog. N to the O equals to the G. Because no is the G. See? No equals to G. So guys and gals, that's log and exponents. No relationship. I'm going to give you a few trick hints. Star. Actually, no, before I do it, give you this. What if I give you something a little bit more tricky? C plus D to the power of F equals to U. C plus D to the power of F equals to U. That is exponents. I can't work with exponents. Some of you say, Mr. No, bring it to logs for me. What would it look like in log form? Look at the pattern. Look at what goes where. Okay? I'm a nice guy, so I'm going to give you a hint. It's going to be log of something. Go for it. I'm a nice guy. Start. I'm going to pause it. I'm going to walk around. And I'm going to come around. And so I walked around, and I noticed one thing. A lot of you said, hey, let's do this. C plus D. And this is going to be U. And this is going to be F. That is correct. So now somebody say, what's the trick to knowing this? Here's how my famous little trick works. Star. If something is a base, it will always be a base. Always be a base. Good question. So let's look at this. I'm going to look at the exponent form. Would you agree that this n is a base? If I look at the log form, hey, look where the n goes. It's also a base. So whatever the base is in your exponent, it will be the base for the log. Whatever the log base is, it will be the base for the exponent. So look at that, base. Okay. Try this. Again, if something is a base, it will always be. No matter how tricky I make it, it's the same concept over and over again. Log. R x power of 3q plus 2 equals to x plus 1. I want you to write this in exponential form. Look for your base. Find a base first. Whatever it is as the base, it will always be the base. There's no exceptions to that rule whatsoever. Okay? I find a base. Look, here's my base. Start with the base. That's the easiest thing to work with. So this becomes R x to the power of, and let me ask some random students here and there. Eeny, meeny, miny, mo. Let's ask Gavina, you're up. What's your exponent going to be, Gavina? X plus 1 is correct. Okay. Equals to, Robert, what's it equal to? 3q plus 2. Hey guys and gals, you should be good with two forms, exponent form and log form. If I give you one form and you hate it, convert to exponent form. You like it. Now, let's solve some questions. Solve without using calculator. Solve. Going to give you some random questions. Log base 5 of 125. If you don't like this form, convert it into another form. Equals to x. Solve for x. If you can't work with log form, convert it to another form you like, which is exponent form. There's only two forms to learn, log or exponents. You got to learn how to convert back and forth, back and forth. Just convert back and forth, nothing more. 5? Ooh, whoa, 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 whoa. 3. Because watch, I'm going to convert this to exponential form. If you're stuck, just convert. 5 to power of x equals to 125. Two ways of doing this. You can say, hey, let's just use a calculator and we'll just fidget around with. And that's 5 times 5 times 5, 3 times. Or you can do what I taught you yesterday and say, hey, Misso, I'll just make all the bases the same. Up to you. They're all, any technique you like, I'm not going to be picky. Yesterday's part was to gear you up for exponents, how to see the relationship. Okay? Once you see it, life gets easier. Try this, a bit more challenging. Solve without a calculator. I'm going to push you guys. See how far I can push you before you break down. Log base 2 of, let's say, 32. I don't need a calculator for this. No, solve it. Equals to whatever you want. What does it equal to? Equals to. Go ahead, add in your own x. You don't need me to add in x for you. You're a big boys and girls now. I'm a big kid now. What does it equal to? Jasmeet, what is it equal to? Jasmeet, take a guess. Wait. Equals to, sorry?
It's equal to 4?
Close. 5. See, if you're stuck, watch what I'm doing. Because if you're the person that hates logs, I'm going to convert this. I don't know what it is yet, so I just put a little box. This is 32. Now I play the mind game. 2 to the power what?
Also, we're looking for the exponent.
Yeah. Because log really is, what is exponent going to be such that it gives you this number? That's what log is. See, log and exponents, I'd say they're really all related to each other. I call it fancy way. But the book calls it something more technical, which you don't really need to understand. And this is the answer is 5. Voila. Okay. Very, very nice. Nothing too bad. Keep it simple. Logs. Now, when on the first day of class, I said we don't use any formula sheets in this class. There are 22 formulas you have to remember in this class. You're going to hit the first 10 today. Actually, I find the first 6 today. Log rules. You got to burn these rules into your head like there's no tomorrow. First of all, I'm going to show you basic log rules. I call this log rules is going to be multiplication. Okay. Multiplication rule states this. Log A dot B equals to log A plus log B. That's called multiplication rule. Now, I'm going to give you an example so that you understand how this rule works. Log of 100 times 10. Guys, gals, you,
A plus B.
A plus B, yep. Log of A plus log B. Let's use the multiplication rule, break this up, and solve it on your own. So go ahead, use the multiplication rule now, break it up. And give me an answer. No calculators. You're not allowed calculators for this part. All you need is just some basic stuff. 3? Nope. Not 3. 3 is part of your answer. It's 3 plus something. See, this I can break it up into log of 100 plus log of 10. Oh, actually, no, your answer is 3. Haha. I'm just bugging you. I'm just testing you. Good job. So now, what's log of... I know what log of 100 is by heart. 2 plus log of 10. What's log of 10? 1. Hey guys and gals, the answer is simply 3. That's how we use the multiplication rule. First one done. Now, I nicknamed this first rules, I call this my Fab 4 rules. Fab 4. The reason why is, when I was in university, back about 2 years ago, I always hang around with a group of my friends. And my friends nickname me, I hang around with these 5 girls all the time. And my friends made fun of me and called them, hey, who's your Fab 5? Okay? So these Fab 4 will always be around you guys all the time because these are the most important rules you will ever use for logs. Fab 4. Next one, division. They will hang around you until the day you die. Okay? Division. Division is the key one people make errors with. Log. Open bracket. Ooh. A over B equals to log A minus log B. I'm going to show you where people make mistakes. I've seen it on exams many times. Put a star here. 1 log. See, this is only 1 log. Not. Please don't do this. Log A over log B. There's a huge difference. This is only 1 log, not log A over log B. Students think it's log A divided by log B. That's your division rule. Next. Exponents. Sure. After I finish all my things. Exponents. Log x to the power of n equals to n log x. So look where I put this exponent. I can bring the exponents to the front. Okay, that's called exponent rule. Because I call it exponent rule because I can bring the exponents to the front. I'm going to give you an example right here. Example, log 100 to the power of 90. If you try to do 100 to the power of 90 and log on your calculator, you're going to get an error because that's some insane number. But really, guys, do we need a calculator for this? No. You can do it in your head. Your head is more powerful than a calculator. Get cracking. What's the answer to this going to be? I'm going to ask a random student soon. And I'm going to ask someone who starts with the letter D and ends in the letter J. Doraj. You're up. What's your answer going to be? You don't know? Where can I bring the 90, Doraj? To the left. Oh, no. Go 90 times log of 100. Agree? Monica, what's log 100? 2. See? So all we're going to do is go 90 times 2. Oh my, no. It's so easy. Voila. No calculators. It's all based on log rules. The key to logs is how well can you remember these formulas. I don't give you a formula sheet. The reason why? People rely too much on formula sheets and they don't know what they're doing. One last one for your Fab 4. This is called the calculation rule. Calculation rule. Calculation rule, I nicknamed this because get your calculators out. You can only do this with a calculator. A lot of people have issues with this because they don't know what to do when they have a calculator. For example, log base A of B. I can rewrite this as log B over log A. Notice what I did. The base now, I changed it to base 10. See? This base was an A, but I changed the whole thing to base 10. Here, your example, it says solve log base 3 of 5. Now, if you look at this question right now, and if you punch log 5 in your calculator, it doesn't work. The reason why? Your calculator only works with base 10. This here is the base 3. So to work around this, you got to use the calculation rule. Let's rewrite this as something over something. So let's rewrite it right now. Something over something. I'll give you a hint. I think it's log and log. Log 5 divided by log 3. Punch this in your calculator for me. So it'll be log 5 divided by log 3. 1.46. This is called calculation. It's only used when I'm asking you to solve questions like this. What's log base something of something? Now, which means this. So we know 3 to the power of 1.46. So let's try it in your calculator. 3 to the power of 1.46. You should get it equal to 5 dead on, or close to 5 as much as possible. 3 to the power of 1.46. Bada bing. 4.9. So that's what it does. So log allows you to find out the number so that you can get the exponent to. Nice and easy. Guys, I was going to give you a few practice questions with calculation rule. I want you to solve these. Solve to 2 decimal places. Because a lot of people are weak on calculation rule. A. Log base 7 of 10. B. Log 4 of 6. C. Log of 15. Actually, I will give you 3 questions. I'm going to pause it. I'm going to let you have some fun. So if I just look at this, I can rewrite this as Manu. What can I rewrite A as? Log 10 over log 7 is correct. And I just easily punch this in my calculator. Log 10 divided by log of 7. Bada bing. 1.18. Which one goes on top, you say? You mean? Which formula to use? Well, because this one fits this criteria. Log base A of B. There's nothing else. Okay, before, we have exponents. Before, I had division. Or I had multiplication. Okay?
Yeah, but how do you know which number goes on top, which number goes on the bottom?
Whoa. Are you talking about bringing 10 to the front? No. See, I'm going to show you the difference. The exponent rule states this. Let's say log base 3. Oop, come on, my pen. Base 3 of 5 to the power of 4. See the difference? I can bring now, there's an exponent to this number. I can bring 4 to the front. I can't bring 5 to the front because 5 is not an exponent. That's the difference. Yeah, there is later in life. Later. Right now, you're just learning to walk. I'll make you run later. Okay. So, guys, gals, next one. Monica, what's the next one going to be? Log 6 over log 4. That's correct. Okay. No tricks. I'll slowly build you up. Log 4 gives you 1.29. See, keep it simple. I don't want to make it too hard. 1.29. Here comes the fun part. Meeny, meeny, miny, mo, run deep. What's this going to be? Over what? You could. Trick question. I don't need anything fancy. I just punch in my calculator. Reason why is, look, this isn't base 10. If it's in base 10, I can just punch in directly in my calculator. If it's not base 10, that's when I have to use the calculation. The calculation rule allows me to calculate any log. So this is 1.17. There's no tricks to this one. The reason why? It's in base 10. If it's in base 10, I don't need to do anything fancy. Any other bases? Yes. Guys, gals, I'm going to let you memorize these. I'm going to pause it. So now, that you have a chance to practice and memorize the formulas, I'm going to show you how you're going to apply them. You're going to use all the formulas and tricks. You're going to solve this. Solve. No calculators allowed. I want to see how you can push it to the next level. Log base 3 root 3. No calculators. Oh, how should you do this? I'll give you a hint. I've taught you yesterday that you really never work with square roots. I've taught you how to convert this into exponents before. How do you write that exponents? Think about that. Yesterday I said square roots you can never really work with. You're going to write this as an exponent form. Go back to your notes on square roots. I said there's a way to get rid of square roots and turn to exponents. You have to know that method. Because on the exams, it's going to be pure exponents you got to work with. This will be log base 3 of 3 to the power of something. Not 2. 1 over 2. Now some of you say, hey, so you lie, you didn't give me that notes. Good thing. Okay, anyways, I'm going to show you. So if you're lost on where this comes from, watch. Square roots really are exponents. Here's how it works. Square roots. We're going to create a little chart. Square roots and exponents. Exponents. The square root, that's the square root. Okay. The exponent form is 1/2. But sometimes I may not have square roots. I may have cube root. What's the exponent to that? 1 over 3 is correct. Okay. Look at the relationship. So you never work with roots anymore. Cube root, fourth root, it doesn't matter what it is. You always convert to exponents. So guys, gals, I got up to here. Solve it now. What do you do next? There's a rule, Fab 4 rule, that works right off the bat. What Fab 4 rule do you see? Exponent 1. Go apply the exponent rule for me. Okay? So exponent rule says, hey, look, I see an exponent, so let's drag it to front. I'm going to drag it. 1/2 times log base 3 of 3. Let's look at the log base 3 of 3, and I look and say, hey, look, there's another rule I see. This is all about log rules. The more you practice this, the more rules that comes into your head. And log rules. I need to meeny, meeny, money, mo. Sean, what log rule is this? Starts with a C. Calculation rule. Because it's not a division rule, it's a calculation rule. So I'm going to rewrite this as 1/2 log 3 over log 3. Agree? And what's log 3 over log 3? 1. So it crosses out. It just becomes 1. Hey, that's your answer. I don't need a calculator. I just need my brains to use. Guys, gals, a bit more challenging. Good luck.
Wait, hold up.
Whoa. Sorry?
Wasn't this the exponent rule in the starting?
It is. I used a lot of rules. Exponent rule, right off the bat.
So you can use 2 rules at once?
You can use 4, 6. You can use every rule. Yeah. On your exam, you have to be able to look at it and say, hey, I see this rule, I see this rule. I'm going to use it all in one shot. Try this one. Without using calculator. Log b root b. That's b times root b. And this is base b. No calculators. I'm going to pause it, let you try it. Before you can do anything, look, there's many ways of approaching this. One way is to say, hey, look, I'm going to show you method 1. Some of you say, hey, Mr. I see there's multiplication, so I can write this as log base b plus, because multiplication, log base b of b to the power of 1/2. Multiplication says I'm going to break this up into 2 parts, a plus b. Guys and gals, I want you to solve what's log base b of b. Solve that for me, please. That will give you a nice number, 1. If you're lost where it becomes 1, I can write this as log b over log b by using the calculation rule. What about this? What does this become? Not 1. 0.5. Because first I got to bring the 1/2 to the front. And you get 1/2 log base b of b, which just becomes 1 plus 1/2. Which gives me 3 over 2. That's method 1. Method 2. Some of you say, hey, can't I just simplify the bracket first? The answer is yes, you could. See, method 2 is log base b, b times b to the power 1/2. You're multiplying similar bases, so we go ahead and add the exponents right now. Okay? Because you multiply similar bases, you add the exponents. So this comes log base b, b to the power 1.5. And that gives you 1.5. Okay, let me explain again. I'm adding the exponents. 1 plus 1/2 gives me 1.5. Then I can bring 1.5 to the front because of my exponent rule. Try this. This takes a bit of practice, but you guys will get better and better over time. It's going to say solve for x. Log base 5 of x equals to 4. Good luck. Solve for x. I'm going to see, I only taught you two forms. One is log form, one is exponential form. If you're stuck with log form, let's rewrite this using exponential form. In exponential form, banana, what is it going to be in exponential form? No, not 2. What's the base in this one? The base is a 5. Whatever is the base, it will always remain the base. So it'll be 5 to the power of 4. Okay? Equals to x. Guys, gals, go ahead, punch in your calculator. 5 to the power 4 gives you 625 equals to x. Voila. I'm going to give you just one or two more questions like this, and we're going to do some more tricky ones left and right. What if I give you this? Log base a of b equals to 7. Log base a of c equals to 4. Find log base b of c. What's log base b of c? You need a calculator for this one. This is all about rules. You gotta look at it and see what rules are being asked, what rules am I being forced to use, and use it. Who haven't asked in a while? Just Kieran. Take a guess. What's the answer going to be? Still working on it? I'll give you a hint. Look at this right now, Just Kieran. What rule do you see? Calculation rule. So let's write this as log C over log B. Now in the calculation rule, guys, gals, you can write down whatever base you want. Let's just put a little a here and a little a here. Normally it's just base 10, but you can write down whatever base you want. Okay. So I know, then we just look at here, log base a of c equals to 4. So we write down 4 on top. And it says, hey, look, log base a of b equals to 7. So we write 7 on the bottom. So just 4 over 7. No tricks. Okay, it's all based on rules. Can you see the rules? How well can you see the rules? Solve. I'm going to give you just random questions until I feel you're ready to do your homework. Log base 3 of 2x minus 1 equals to 2. Solve for x. There's only two forms, right? If you're stuck, if you don't like the log form, get rid of it. So I only taught you two forms. If you don't like one form, convert to another form. If you don't like exponential form, convert to log form. It's just back and forth, until one of the forms you get a nice answer for. Meeny, meeny, miny, mo. ZNet, I don't think I asked you yet. ZNet, are you going to work with log form or are you going to convert it? Convert it. So what if you convert it to exponential form, what is going to be ZNet? Sorry? 3 to the power of what? 2 equals to 2x minus 1. Right? All it is converting. Converting from one form to another. If you can't work with logs, convert to exponential form. They're really...
So you can do that for anything?
Yeah.
What are the rules for it?
So you don't need the rules?
The rules is only when you have logs and you can't convert.
How do you know you can?
I'll give you, relax, breathe. Breathe. Like, we have lots of times for that. 9, I'll give you, don't worry, you give it. There will be lots of time for you to run. For now, you're going to walk. 2x minus 1, and we solve. Okay? So x equals to 5. Very nice. Okay, no tricks. Now, some of you ask me, so when do I use log form, when do I use exponential form? I'm going to give you an example of a question that you won't be able to solve yet, but you may be able to solve it later. Log base 3 of 2x plus 4 plus log base 3 of x equals to 2. In this example, would you agree that you can't convert to exponential form yet? Because there's too many logs everywhere. You can't convert to exponential form yet, but there's a log rule you can use right off the bat. Multiplication. Use a multiplication rule right off the bat. See? It's all about using logs, rules, and converting back and forth. Logs really and exponents go hand in hand. I look at this and say, hey, look, there's a multiplication rule. Log A plus log B. Go ahead, simplify this right now. Log base 3. Guys and gals, what the heck goes in this nasty bracket? Ooh, whoa, whoa, whoa. 3x? Nope. 2x squared plus 4x equals to 2. Guys, remember, this is called multiplication rule. Multiplication rule states this. I'm going to multiply these two brackets together. Because that's the multiplication rule. The log base 3, 2x plus 4 times x equals to 2. Okay, that's the multiplication rule. So now I have to when I multiply it out, I would get exactly this. From here, you can go ahead and write an exponential form right now. See? 3 to the power 2 equals to 2x squared plus 4x. And you can solve it from here, which I'm not going to make you do, because that's for later. You're not ready at that stage yet. Even though we just got up to here, but that's for later. Yep, question.
Can that actually solve it in log form, or do we have to always switch it?
No, you could solve in log form later. But for now, you're going to just work with exponential form. It's too complex. There's only two forms, exponential form and log form. Yep. If, like I said, it varies on the question that you can try convert back and forth. Guys, whoa. In my class, I said there's going to be no rewrites for exams or quizzes or anything. You get a one time for your mind, one shot. Your quiz, there's no rewrites. But I'm going to give you a chance to earn a rewrite. I got the first supernova question for the year. You don't get a card. Guys and gals, here is your supernova question. Earn your card.
Wait, did you say we could rewrite the test?
Oh, there's no rewrites in my class.
You just said you.
Whoa, nope. You gotta earn these cards, remember.
No, you said.
Oh no, there's no rewrites. You gotta, in Math 12, you got a one-shot deal. Here's how it works, super no. Solve for x. I'm gonna give you 4 minutes. There's gonna be no talking. You're gonna circle your answer. And I'm gonna walk around in 4 minutes. You get it right, I give you a card, and that's it. This is gonna be log base 2 open bracket log base 3 open bracket x minus 1 equals to 1. Solve for x. You got 4 minutes. I'm gonna pause it, and if I look at this question, a lot of you are confused because you see so many logs. See, it doesn't matter how many logs there are. I said you can't work with this right in exponential form. How would you write this in exponential form? Nope. You're going to start with 2 because this is your base. Agree? 3 is a base also, but we're going to start with the last one, the biggest log outside. 2 to the power of 1 equals to log base 3 of x minus 1. Agreed? Now, would you agree 2 to the power of 1 is just 2?
Yeah.
So let's rewrite this again as log base 3 of x minus 1 equals to 2. Hey! Oh, look at that. Look what I just did. Boo.
It's the same thing.
Wait. This and this?
What the?
Yeah, exactly. See? I had 2 power 1's 2. So instead of writing 2 on the left side, I just wrote 2 on the right side. Hey, now what did I do? I write it in exponential form one more time. So did I need 4 minutes to work on this? No.
Grandpa, why did you get it?
See? All it is what exponential form. No matter what this is, like I said, I gave you some funky thing before. It doesn't matter what it is. Exponential form is you take the base to the power of this equals to whatever this is. It doesn't matter how big it is. That's now 3 power 2 is 9. 9 equals to x minus 1. X equals to 10. That took less than a minute. I gave you 4 minutes. Okay? That was actually a provincial exam question. And only, like I said, only about 3 people, and then I was right, only 3 of you got it. Because on provincial exam, on average, only about 3 out in the class will get it. So this, I do this question every year, and every year, only about 3 or 4 kids will get it in their first try. Okay? The reason why is they can't see right through this. Because I give you a question like this before. I said log base 2 of c plus d equals to 4. It doesn't matter what this is. Okay? It doesn't matter how big that stuff is. I do the same concept. C plus d in this case really is that big nasty thing. Okay? So guys, gals, that's the power of exponents. That's what logs is. Log and exponents go hand in hand. I'm going to give a break, and I want you to try some questions, Joan. Page! 32. Number. Yep. 1 to 4. 6 to 13. Well, basically omit 5. Okay, that's it. And again, you will get a quiz on this tomorrow. No, as always.
Oh, let's do it online this time. Just
Online quiz, please.
when are we having online quizzes?
I will let you know. So guys, gals, that ends your lesson for today.
Mr. No.